Thank you guys for going over that in your breakout rooms. Some of you said we need 70 milliliters of the 10%. Another group said we need 130 milliliters of the 10%. And then one group said we just need 100 milliliters of both. So remember, we're making the dosage for children of the vaccine, and it is important to mix it properly so that we do have the 36% solution in the end. I'd like you to go back to your breakout rooms. I'll put in the chat those 3 solutions, and I want you to figure out which one is correct and why. On your marks, get set, go. Thank you for going over that. You do have the correct answers now. So we do need 70 milliliters of the 10% solution and 130 milliliters of the 50% solution. Remember, as we're studying solving systems of 2 equations, you need to plug into the x and the y that you've defined the ordered pair that you found for the solution. Remember, the solution is any ordered pair that makes both of the statements true. You can always check that by plug it in, plug it in. Okay, so if you've plugged that in, then you can see, oh yeah, some of you just switched the variables, and make sure you define those and put those in properly, and said, I need 130 milliliters of the 10%, but that's really how much you need of the 50%. So be aware of that and make sure you check when you need to. Okay, great. I now want you to try this problem on your own. I'm going to give you a few minutes to work through it. I'd like for you to please send me your solution in a direct message in the chat. Okay, on your marks, get set, go. Thank you for sending those messages and for taking some time to ponder this problem. There are a lot of discrepancies, so we need to figure out what's going on here and how is this problem different from the last one. As you remember, we've been talking about solving systems of equations, and we're talking about mixing things. So here, remember, we have this little template that I showed you. We have the amount equation that you write first. It's adding your 2 variables, and that equals the total. So we talked about this being a physical amount. If we're talking about chemicals, you're physically pouring in this many milliliters and physically pouring in this many milliliters, and then how many milliliters do we have at the end? We also talked about a value equation. So the value equation just tacks on a value to those. You have a specific value times the x, and then you have a specific value times the y. And that equals, and don't forget, there's also a value that you want for the total. In the problem that we just did previously, all you did was plug in the pieces they gave you to this little template, and then you figured it out. But what happened in our problem here? So if we go back and look, we see that the other clinic has 130 milliliters of the 50% solution. They also have a 20% solution. How much of that 20% solution do we need to get the dosage? But they never gave us the total amount. So math models the real world, and sometimes the real world is complicated. And we need to take the knowledge and the patterns and the connections that we've seen before and what we have and apply it and tweak it a little bit and be flexible to make changes. I know that sometimes this is frustrating for students. You just want to see how it's done every time. But it's really invigorating to push your thoughts, and sometimes you just need to step into the dark. Have that faith to take that step, and that will lead you to where you're going. I know Heavenly Father loves you guys so much, and He wants you to understand these concepts. The glory of God is intelligence. He wants your mind to open, to make connections, and to be able to think through processes that you haven't been shown before. It's really invigorating and it's fun. So let's try this. Okay, I'm going to put you in your breakout rooms for a few minutes, see if you can figure out how this problem is different from the last one, and how can we plug it into our template. On your marks, get set, go. While they're in their breakout rooms, I send a message to all of them to please send me a screenshot of their work so that we can look at it and discuss. Thank you all for sending me your screenshot. I have these up on the whiteboard now for us to look at. I've labeled them A, B, C, and D, and I'd like you to please tell me which one you think is correct. Okay, yes, you're right. Group B had this correct, and we can see what they did with the information given. And thank you for thinking through that. And let's go through this together just to clarify how you could think through this process. So first of all, you want to write this amount equation so you know that you have x plus y equals the total. In the problem, you weren't given that total amount. You were given something else, and that was the 130 milliliters for the x. Now, how could you write the value equation? Just step and step and step until you get where you want to be. Up here, when you start this process, remember, you need to label. So we labeled the x. This was the 50% solution. And then we labeled the y as the 20% solution. With those labels, now we can make sure we have our value equation written properly. So we have 5/10 or 50% times the x, which we would usually write x there, but this time they gave us the total, 130 milliliters. And then we have the 20%, or the 2/10, times the y, which we don't know, that's what we're trying to solve for. And that equals the value. Remember, this is the children's dosage, so it needs to be 36% of the solution times the total. This is where we usually had a number, but we don't. This time we have the 130 plus y. This acts as our total now. Just a little change, but still using the connections and the patterns that we've had in the past. Okay, wonderful. Now you can go through and multiply and multiply and combine like terms and solve for y and figure out how many milliliters of the 20% solution you need. I want you to do that on your own, and please throw it in the chat. On your marks, get set, go.